Hi, so today we're going to go through electron configuration. We already did a lot of this in class, but I want to take time to emphasize the three rules that go with this, as well as talk about how to come up with the electron configurations for specific atoms and how it's kind of laid out. So to start with is, what is electron configuration? We refer to electron configuration in two ways. First is the actual notation that we as scientists will use to express the configuration of the atom. And secondly, it's the actual way that the electrons exist within the atom themselves. Remember, there are three rules that dictate how the electrons organize into their ground state. And just as a reminder for what this term is, we'll talk a little bit more in depth about this next week, but the ground state is the lowest possible energy arrangement for an atom. That means all the electrons are as far down the energy levels as they can be. And these three rules are the off-ball principle, Pauli's exclusion principle, and Hund's rule. First, I want to look at Pauli's exclusion principle. This principle states two things. First, each orbital, which is there's one orbital in S sublevels, there are 3 orbitals in P sublevels, there are 5 orbitals in D sublevels, and 7 in F sublevels. Each orbital, once again, 1 in S, 3 in P, 5 in D, and 7 in F, can only have 2 electrons at most occupying it. We can't have any more than that. Second is that the electrons, when they're paired in an orbital, they must have opposite spins. So just remember real quick that spin is our way of describing the motion of an electron. The best way to think about this without getting too quantum mechanic-y with it is just kind of think clockwise, counterclockwise. If we have a clockwise electron, its partner is going to be counterclockwise. So, I want you guys to look at the 3 diagrams on the right. Which one or which ones are correct according to this principle, according to Pauli's exclusion principle? Which ones displayed are correct, and why are they either correct or incorrect? Okay, so for letter A is incorrect because this goes to our first part of Pauli's exclusion principle. If you look in the 3rd orbital of 2p, there are 3 electrons. We cannot have more than 2. So that should already jump out at us as, hey, that's not quite right. Letter B is also incorrect. And for this one, it's because in the 2s orbital, the electrons that are there have the same spin. Remember, they have to have opposite spins. And letter C is correct. Letter C is correct because it follows both of those principles. Each orbital has only 2 electrons, and each electron, when it's paired, is spinning in the opposite direction. Okay, so moving on. The second rule that we're going to look at is Hund's rule. Essentially, with Hund's rule, electrons don't want to be near other electrons. And I've talked about this in class. Remember that they are these negatively charged particles, and they will naturally want to repel each other. So they won't want to be near each other if they don't have to be. Essentially, electrons will want to fill empty orbitals in a sublevel first. So they won't partner up. If they don't have to partner up, so if there is an empty orbital on a given sublevel, they will go to that empty orbital first. So that means as we put as we add electrons going from element to element to element, and as we fill up those sublevels, the orbitals have to be filled one at a time first. So if we're looking at our 2p sublevel, if we look at 2p, each of those 3 orbitals has to have 1 electron before I go back and start pairing them with another. And as I stated at the beginning, electrons don't like being around each other if they don't have to be. And when I say have to be, we'll talk about that on the next few slides when it comes to Aufbau's principle. But in general, is they don't want to partner if they don't have to partner. Now, just like on the last slide, I want you guys to look at these 2 diagrams, and since these are unlabeled, we'll say A and B, top is A, bottom is B. Which one is correct and which one is incorrect based on Hund's rule, and why? Okay. For these 2, we'll start with the incorrect one first. The bottom one, letter B, is incorrect because, as we can see, if we look at our 2p orbital, we have 3 electrons. We have our 3 electrons. They would want to pair as is shown in model or in letter A. They want to be on their own first before they have a partner paired with them. And lastly, just to give the pattern, this is how electrons would naturally want to fill a p sublevel. So going from top to bottom, if we look at that 2p sublevel, that 2p orbital, starting with 1 electron, it would start clockwise spin in the first box. The second electron, same thing, clockwise spin, second box. Third electron, clockwise spin, third box. And then we go back to box 4, 5, and 6 as we add more electrons to add the counterclockwise partner. The last of the 3 rules is Aufbau's principle. Now, in class, I talked about this one first, but I wanted to save this one for last because, in my opinion, Aufbau's principle is the most important of the 3 rules when it comes to how electrons want to naturally arrange themselves within an atom. The Aufbau principle, Aufbau meaning filling, if I remember correctly, the way that atoms will want to fill is based on this principle. Overall, for a lack of a better description, electrons want to be where they are most comfortable. Okay, so I want to give you a for instance. I want you to picture our classroom, okay, my classroom at Riverview. There are 3 or 4 seats towards the back of the room that are right in the window. As the day wears on and the sun continuously beats down on those windows and beats down on those seats, they get warmer and warmer and warmer and warmer. And there are some students who find that uncomfortable. So that is not the most ideal spot for them. It is not the most comfortable spot. Or, and a better example would be, think about how long my room is. When you come in, I want you to count. There are 17 desks from the far side of the room all the way to where the flammable cabinet is. There are 17 desks. If you think about the way that I put you guys on my seating charts, I put those of you, as many as I can, directly in front of my board. So further to the far side of the room, because that's where my board is. Because as I get more and more and more students, I have to find a place for them. But as I shift further towards that flammable cabinet, it becomes more difficult for those students to see the board or to hear me or to do whatever they need to do because it's harder to see, harder to hear, whatever. So those spots are not ideal for them. And it kind of works the same way with electrons. In terms of comfort, electrons will go for the lowest energy orbital first. That means that if there's an orbital or a sublevel with the lowest energy that has a spot for an electron, they will prefer to go there. And like I said on the last slide with Hund's rule, do electrons want to be paired with each other? No, they don't. But they would rather be paired with someone and be in a lower energy level than to be alone on a higher energy level. They want to be in that lowest energy level possible. And that's the main idea of Aufbau's principle, is that the lowest sublevels get filled first. And I want to reemphasize that. The lowest sublevels will get filled first. So, in ground state, and remember we talked about ground state, electrons will want to go to those lowest orbitals first, where the atom is in its lowest possible energy arrangement, and that's where it'll start. Now, we've been talking about ground. We'll go into excited a little bit more this week. So, looking at the diagrams on the right, I have 5 diagrams here, A, B, C, D, and E. Which one of these 5 orbitals is incorrect based on what we just talked about with Aufbau's principle? Which of these 5 orbitals, A, B, C, or D, is incorrect? And why is it incorrect? So don't just tell me which one, but tell me why. Okay. So, as most of you probably guessed, letter C was the one that was incorrect. This is because if you look, that 2s sublevel is completely empty. 2s is a lower energy level than 2p. So the electrons would want to fill there first. Okay. So I'm going to take a pause here, and this will be the first half of this set of notes. I have a little bit more material to go through, but I don't want to make this video overlong. So this is where we'll cut it for now, and we'll go from there.